Okay, we were stuck on number 11. Okay, let's take a look. There are two approaches how you can approach 10 through 16. Each one of these involves just slightly different variations on how to get to your solutions. The first way works great because you just set up cosine, you find the missing values, and you set it equal to 0 and solve. Works fine. 11 is a slightly different technique that I want to showcase at this point in time. So normally, we use Pythagorean's theorem at the end, and we find our components using the trig function at the beginning. This time, I'm going to work just a little bit in reverse and use Pythagorean's theorem at the beginning, and then find the different ratios to solve it at the very end. Here we go. So first thing I want to do, just like in the previous problem when we talked about 10 before we went to lunch, we know this statement right here to be true. Now that means it has to be true for this specific component. The problem is, the 1 over 2 deals with B and deals with C. They don't have a number we can actually work with there. They're both variables. So I'm going to make one of them a number. Ready? I'm going to start by recognizing that, remember, from geometry, these two have to be similar. Because keep in mind, this trig function 1 over 2 works for infinitely many triangles. It works for 1 over 2. It also works for 10 over 20, 100 over 200, and that's just the easy ones. It also worked for 4 over 8. Because again, when you reduce it down, it's 1 over 2. So there's a lot of things this could be. I want to figure out what this specific one is. I'm going to do it using Pythagorean's theorem. So I'm going to start by making a similar triangle where I focus on this relationship. So this side is a 1, that side is a 2, and this side is an unknown, so we're going to give it this little star. Step 1 I'm going to do, Pythagorean's theorem. So use Pythagorean's theorem on this triangle. So I would do 1 squared plus the star squared equals 2 squared. 1 squared is 1. Star squared is just star squared. It's a variable. 2 squared is 4. I subtract 1 from both sides. Meaning I get star squared equals 3. I square root both sides to get star by itself, telling me that the star value is the square root of 3. Which means for this triangle, which again, from geometry, these are supposed to be similar, meaning they have balancing properties. So I know this triangle has similar properties to the other one, which means that the cosine of this triangle will match the cosine of this triangle. The tangent of this triangle will match the tangent of this triangle, the same way sine should. So what I'm going to do now is I'm going to pick one of the other trig functions using this triangle and work backwards like we did on number 10. Here we go. So in this case, this is B over here. So we have 1 on the opposite side, 2 on the hypotenuse, and square root of 3 on the adjacent. I'm going to use cosine. So according to this triangle, cosine is equivalent to, so cosine of B is equal to the adjacent, so that would be square root of 3 over the hypotenuse, which is 2. Well, that's the same thing that in this picture would be equivalent to 20, which is adjacent to this picture, over C. So now I have that same equation that I had on number 10. We end up with two fractions, square root of 3 over 2, 20 over C, equal to each other. I go down, cross multiply, I get the square root of 3C equals 40. Divide by the square root of 3 on both sides, I get C equals 40 over the square root of 3. Or, there's two versions. I could give the radical simplified answer or the decimal version. The radical simplified answer for this one would be 40 square root 3 over 3. The decimal version of that answer would be 23.7. Something weird, something really nasty. Izzy, would you mind? You type in either one.
23.1.
23.1? So that gives us two sides. Now I could either use Pythagorean's theorem again, or I could just use a different trig function the same way we just used cosine. So notice we use the sine to set up this triangle, use Pythagorean's theorem to find the missing side, and then any trig function that is true for this triangle must also be true for this triangle. Because that's the way the trig functions are designed to work. Let me put this in a more broad scale up here on the board. I'll try to get it very precise here based upon the little pixels I have. So this is a 3, 4, 5 triangle. So one side is 3, one side is 4, one side is 5. If I label this angle here as A, then I know from this picture, sine of A is the opposite over the hypotenuse, so 3 over 5. Cosine of A is the adjacent over the hypotenuse, so 4 over 5. And tangent of A is equal to opposite over adjacent, so that would be 3 over 4. But what if I picked a different triangle that had similar properties from geometry? Similarity meaning it's a scaled version of the other one. What happens is the trig functions look different until you simplify them. Take a look at this version. What if instead of having a 3, 4, and a 5, I had something like a 6, 8, and 10? And again, I have to use this one as my A in order to match them together. But if I was to do the trig functions for them, they'd still be 3 over 5 for sine. Because if I did the sine value of this A, sine over A would be opposite, 6, over hypotenuse, 10, which is just 3 over 5. So the numbers aren't 3 and 5, the numbers are 6 and 10, but they reduce to the same values. If you look over here, when I do Pythagorean theorem on this one, the missing value, the one that's left, the B, as it turns out, is actually 20 square root 3 over 3, or 11.53, something like that. So if I was to divide these two numbers, the sine value, right? Because sine, remember, is opposite over hypotenuse. When you divide these two numbers, you do get 1/2. Just like you're supposed to. They're just weirder numbers. But that's always going to be the case. You may always, at any point in time, draw a similar triangle with the reduced values that must maintain the same properties of the original triangle with its non-reduced values. So, example, if I wanted to find the missing sides on this picture, at 8, I could always do Pythagorean theorem, of course. Or I could set up a ratio between these two, just like we did over here, and find that missing answer. Now, certain problems use this technique. Some problems use the same technique to use at number 10, where you just set up the triangle and do the fractions together. Both work equally well. It's just dependent upon the problem. I can't tell you which one you're going to need. I couldn't just look at a problem and be like, clearly for this one you're going to need that technique. I can't do that. But the idea maintains the same. And in fact, I can guess one of these that you will need to do. I think it's number 14. Is when we have to do something very similar to this. So I'm going to try to do the next problem. Pull up. Alright. Let's see. Number 12 should be just like number 10, if I'm eyeballing and guessing correctly. I think number 13 is like number 10 as well. 14 is like number 11. So why don't I try number 14, the same technique again, just so we can make sure we understand where this piece comes from and how to find our solutions.
I don't understand anything I do next one.
Okay, let's take it one piece at a time, Remy, okay? Let's look at number 14. Like I said, number 12 and 13 are both just like number 10, so same format, same setup, which was the easier ones. However, number 14 is like this new setup, a little bit tougher. So, let's talk about what we were given. And here's a picture. We have A, B, C, little A, little B. It doesn't matter, again, this is number 14. Again, it does not matter which place you put A and B, as long as little a is across from A, little b is across from B, and little c is across from C. Now, what we know. We know from this problem, according to 14, sine of B is equal to 1 over the square root of 3. Excellent. And A is equal to 2. Okay, so I'm going to put that information into my picture real quick. First things first. My A is equal to 2. It says sine of B is equal to 1 over 3. B is up here, so that would be opposite. That would be B over hypotenuse C. Red flag should start going off. I have a fraction equal to 2 variables. I can't do that with the same way we did number 10. So I'm going to go now and try to do it the way we did number 11.
Wait, I thought that was a 6. Never mind. Not Y.
Yeah, it should be a B.
Wait.
It's a B over C.
That's why it doesn't work, just because it's B over C, not 6 over C.
I wish there was a better way to write B. Hold on, give me a second.
Yeah, that looks nice.
Better?
Yeah.
Probably better for the back. Up front it looks weird, but. Is it a pregnant I? I don't know.
A little bit.
A little bit?
Just leave it, it's not as fine.
Okay. So what I'm going to do is I can't use this triangle right now because I don't have enough information in the right spot. If I had B, I could do this. If I had A or C, I could do this. I have A. That's a problem. So what I'm going to do is I'm going to make a different triangle with these properties and then work backwards. Here we go. So I'm going to have a very similar picture, just a little smaller. It's almost always going to be smaller, so I always draw it a little smaller. So here's where B is. I want it to match the original picture as much as I can. So there's B, C, and A. Okay, according to this problem, the opposite side, because remember sine is opposite over hypotenuse, the opposite is a 1. So put a 1 there. The hypotenuse is a square root of 3. And you can see how those line up with B and C, and that's actually the problem. We want them to line up with other pieces, but they line up with B, they line up with C. I want them to line up with A. So what I'm going to do, I'm going to find this missing side using Pythagorean theorem. Let's do it. So I would do A squared plus 1 squared equals the square root of 3 squared. Okay, we simplify. A squared is just A squared. 1 squared is a number. It is 1. Squares and square roots always cancel, leaving a 3.
So A squared equals 2.
So A squared equals 2. We subtract 1 from both sides. We take the square root, so A is equal to the square root of 2.
A equals 1.
The square root of 2 is just a number. It's a square root of 2. It's like 1.414, something weird.
1.414.
So for this triangle, it has these properties. But keep in mind, these two will have the same trig functions, the same trig ratios. Sine of this one is going to be the same as sine of this one. Cosine of this one is going to be the same as cosine of this one. Tangent of this one, same as tangent of that one. I'm going to use this one to find my answers up there by just now doing a different trig function instead. So going here, instead of doing sine of B, what if I did cosine of B? So cosine of B states, okay, according to this picture, which remember, they should have the same ratios because they're the same basic picture. Cosine would be adjacent, square root of 2, over the hypotenuse, square root of 3. Remember, they should have the same properties, meaning while this one is square root 2 over square root 3, this one will be 2 over C. Now at this point in time, make sure you have your algebra good, because the next step is cross multiply and divide. Take square root of 2 times C, so square root of 2, C, 2 times the square root of 3, 2 square root of 3. And then divide to get C by itself. So this becomes 2 square root of 3 over the square root of 2. Or the simplified version of this, there's two versions. The radical would be the square root of 6. The decimal would be 2.318. Am I dizzy?
What?
Decimal, please. Divide these two numbers. 2 square root of 3 divided by the square root of 2.
Oh,
yeah, sorry. Sorry, Abby. Fat man in the way? Why'd you say so?
Well, I didn't necessarily say that. Too quiet.
You make a better door than window, Mr. Evans?
I'm also the Mary.
Daisy?
2.45.
2.45. Okay, which means that up here, the C value should be 2.45. Now, once you get to here, there's two things I could do. I could do Pythagorean's theorem now with the top one, because it has two sides known. That's not too bad. Or I could just do a different trig function again, because I have two of the sides known. I have to find that missing side B. So again, both will work. I just need to be able to find out what B is. So I'm going to choose to use Pythagorean theorem. I think it's the easier of the two options. But I have to do it to this triangle now. So according to this triangle, I go to the side here. I got to do 2 squared plus b squared equals 2.45 squared. And if I think I did this correctly, b ends up being the square root of 2 or 1.414. But you'll have to check the work to make sure I'm right. Am I good?
Okay, hold on.
Yes, ma'am. So I'm going to finish the math. So I would square both the 2, so that would become 4. B squared. 2.45 squared is really close to 6. I know that because down here, it's the square root of 6. So the square root of 6 squared would be 6. And then I subtract 4 from both sides to get b squared equals 2. And I square root both sides, b equals the square root of 2. So one's like 11 and like 14, you'll have to do Pythagorean's theorem twice. Once on the trig function, once on the actual triangle. But again, I want to point out a couple things very quickly here. I'm going to pull out my calculator to help with this. Okay, what we started with, sine of b is equal to 1 divided by the square root of 3. Now, I'm going to pull out my calculator. 1 divided by the square root of 3 is a number. 1 divided by the square root of 3 is equivalent to 0.577. Now that I have all this information, watch what happens. I do the sine. Sine is opposite, so 1.414. 1.414 divided by the hypotenuse, 2.45. If this has been done correctly, then I should get the exact same solution because it's the sine. It's opposite over hypotenuse, so it should be this number, which we already know is 0.577. It's a little different, 4 decimal places out. That is because this number and this number are both very close. They're not perfect. They're very, very close. So notice, we got the same, don't crack my door, open it. Yeah? I don't think you're going to want to use it. I'm going to pause my video here.
What?
Boom. All right. Okay. Let's take this one piece at a time. See where these go. Like I said, 10 through 16 are the hardest ones. Let's go back to it.
Wait, what time are we doing this?
This is number 14.
Oh, we're done.
Yeah.
We are. I just want to talk through it one more time. Make sure you know where they came from. Okay. There's a lot of pieces here. Take note.
Do you need to take your recording down again?
I already did. So, right here. This relationship did not apply to the original triangle because we didn't have the right components. If we did, we would have done stuff like we did on number 10. Okay? So instead, we went to this triangle, which has the same properties as the other one. We found the missing side using Pythagorean's theorem. We then use this triangle with a different trig function to find the missing sides.
Is that how we do all of them?
No. Like I said, 10,
Are there
12,
any
13,
more like
and 15, and 16, they all work the other way.
that? Okay, but those ones I can do. It's these ones that are
And we did both of them in class together.
good. Shoot.
10,
I already
12,
You
13,
go over
16.
11
No.
or 10 again.
10, 12, 13, 15, and 16, they all work the same way.
You get upset when we put our homework numbers in the wrong order.
Not really.
Okay, then
I'll be honest, I did the same thing when I was in school, so I don't really notice that much.
okay.
Mine goes 10, 11, 14.
Yeah, mine goes 10, 11, 14.
Especially when I see it's problems we did in class, I'm like, oh, then you worked on those problems, and then went back into the rest of them. I get it. It's all good to me. So?
Wait, which problem?
6.
Oh,
6.
Oh, 6.
this is pretty easy.
I take it you kept promise.
No, I haven't.
That I've been so kind to put on the board up there.
It's on this whole thing.
Okay.
I think that's fair.
What if we just get it turned in by the end of break?
Right? I doubt that'll happen. Because I remember what happens every time.
Really?
Everybody
Then
waits
why
until
are you
like
trusting me to
Monday
get
morning.
it done by Sunday? I mean, I will, but
I don't see.
Okay, just so we have like 10.
That's just longer.
What happens? Everybody's like, I'll do it after things.
Can I explain number 6?
Would you like to ready?
I would.
I would.
Let's see
Please
how much
do number
I
10 because I would.
Who's else? Take a
The
listen.
only reason she has work on me.
Yeah, I do have work on me.
Okay, guys. So number 6.
I might turn it in
I'll
Monday.
rewrite it so we can see. Says C.
Can you help me on 10? 14. I'm
34
trying to cut off the, or actually, the one that
Degrees.
I'm already doing.
equals
C would be
sine of blank degrees. Well, so the formula for sine is 90 minus the angle, so it's going to be 90 minus 34. What is that?
And you just do
It's
Pythagorean, right?
56.
Oh, really? I don't think
The
it's
answer is sine
I'm trying to put, I tried to put what you have on board.
That's it.
56 degrees.
Yeah, the issue is.
That's not side.
Sine of B. Sine of
Do you know how to do it?
I never even read it.
Okay, how do you know if you use the 90
Okay,
minus?
so you.
Okay, so like this one right here,
It's
it's radians. So it would be the radians formula, which is the pi over 2.
So on 7 we use radians.
Yeah, on 7 and 9 you use the radians,
Okay.
which is the pi over 2.
So in this case, the sine of B is would be opposite 1.
Did you need it still?
Yeah.
Okay.
I know it's
Can
right.
you just click
You
back?
just click back. It doesn't bring it back.
Use a tag here to divide this one.
Actually, never mind, I got it. Okay. Rick has got
And use this one. That makes sense.
You broke it.
So that's
That
what,
did.
2? Okay. So those two cancel the sign. They're opposite. And this is actually that means okay. So then now we can do this one. Cosine would be C over 20. Right? And cosine would also be 2 over square root of 3. Oh, okay. So then you would cross multiply. Okay. And sine or tangent would be like E over 20. The tangent would also be 1 over square root of 3. Okay. That's how you find out what pieces. Okay.
So it'd be what? B cosine. B what?
2 over square root of 3. So this triangle has the same cosine. So that would equal the 20 over
C. Okay. And then you just work it out like you did the other problem.
Alright,
Oh,
is up to now.
I got it
Sorry,
now.
it's up to now. Square root of 3 out because it'd be adjacent to that.
Sorry.
Probably such that. Then you talk about that.
I need your help.
Yes, ma'am.
One more.
Okay, so start. Do the same thing we did before. We make the same triangle. What's the B here? There's your problem. It's not my 10. Here, your piece is not. Remember, B is across from B, right? B is 6, so 6 will be right there. And C goes right there. Now you should be able to set up just like 10. Remember 10 states? Tangent is equal to 5 over 12. In this picture, tangent is equal to A over 6. So now you should be able to cross multiply and solve it.
Oh, that's it?
Oh, very nice job, bro. Fantastic.
Giselle, you got it?
So Giselle, she's using the formulas that are on the board up here.
What are we doing now?
In this case, because they're fractional ones, the radians, you have to use the radian version, so that's why, according to the formula, cosine is equal to sine of pi over 2 minus the angle. So cosine of pi over 3 is equal to sine of pi over 2 minus pi over 3. And then the inside just has to be simplified. With degrees, it's easier. Got 1/2. You took pi over 2 minus pi over 3 and got 1/2? How do you do that? Let me see.
I definitely got 1/6.
See, that's not even divided.
You got 1/2? No, you good. I was like, what?
This one. Fantastic, by the way. We're not actually looking for the answer, we're looking for the inside. We're just looking for that piece. So check my
I'm not driving this one. So we don't?
That's why I left it at 6, not 10. Yes, I would.
Oh, so the
Try to see if we can get it.
That's a good point. I didn't think about this. On the first 6, you're not actually asked to actually plug into sine or cosine or secant or cotangent or any of that stuff. You're just asked to find out what numbers should go in there to make them complements. So like on the first one, we said that inside of cosine needs to go 34, so inside of sine has to go 56 because they're complements. On the second one, pi over 3 is what goes in the cosine, pi over 6 is what goes in the sine, and if you type in cosine of pi over 3, you will get 1/2. If you type in sine of pi over 6, you get 1/2 because they do match. We're looking for numbers that go inside to make these two things match.
I was gonna take this for no credit, but I'm not.
I'm sorry.
I was going to, and then I
was
didn't
going
set
to.
up a date to take that.
And then
You
Leo
can
confidently
still
looked
take
me in the
it.
eyes and told me I wouldn't be
I
able
don't
to.
know. I saw it.
You can take it after break. It's just, I mean, we would never say the acuplacer is
But
easy.
it's not time. It took me an hour and 46 minutes to finish it.
That's
not bad.
But then can I pass this class with the grade that I want on my college transcripts or not?
Yeah, I might not.
You don't have to do
I don't
dual
think
credit
that's a
for
good
it.
idea for me.
I'll tell you what is, it depends on the school you go to. That's why I always tell people, talk to the schools you want to go to and find out what happens. Some schools will accept transfer credit, but they will accept it as what's called general credit, meaning you don't actually transfer the GPA, you just transfer the 3 credits. Which if you have a bad grade, it is great. You have a good grade, you're like, I worked so hard. But other colleges are like, no, we want to transfer the grade too, so you start out with like a GPA based upon what your high school GPA was. That's why you should always, if you want to know, talk to that school, talk to their registrar's office, and be like, hey, I'm looking to take this for college credit. Will the grade transfer or will just the credits transfer? Because that does matter.
There's a ladybug.
I'm sorry, that was random.
It's okay if you look in the light bulbs, there's a bunch of light bulbs above you.
Those ones are dead though, that was a lie.
Well, you just think they're dead. They could be like slowly suffering.
I don't think that that's good.
It's not.
It's magic.
What are you playing with over there?
Isn't it like literally a magic trick?
It's just a puzzle. Kind of those cubes you guys played with earlier in the year. Just a different kind of solution.
Skylar Martin, you're needed in the office. Skylar Martin, you're needed in the office, please.
Skylar, what did you do?
Did we really have a fish tomorrow?
Every Sunday.
What? Yeah. It's gonna be
All my grades have stayed an A all semester, and now I failed my biology test, and now I'm gonna flip this in here, and I'm gonna have 2 B's, and I'm gonna cry about it.
I shall drink in your tears.
Yeah, bro.
not that much.